Now we're going to talk about three Minitab functions. Now we've actually described these before, but the process in control is we want to make sure that the process is able, the work process is able to stay in control. So as a green belt analyst, one of the things we'll do is we'll take a look at a couple of these functions and make sure that we have actually created a system that will stay stable and that it will alert people who are running that process to the fact that there are some issues that are involved that need corrective action. The first of the techniques that we'll take a look at is process capability. Now remember, we introduced you to capability analysis in our exploratory data analysis section of your green belt training. So now let's come back and say, what is the objective of process capability analysis? At the beginning, we were trying to find out the difference between best of the best and worst of the worst. Now, we've established now some sort of limits of performance, and what we would like to do is make sure this process will operate within those limits in a consistent basis. So let's see, what do we do in Minitab to make that actually become true? Before we are convinced that this process is able to do what we want it to in the future, one of the things we should do is a process capability study. Now, we learned about those when we were talking about exploratory data analysis. But here the idea is we would really like to make sure that this process will operate stably over time. In other words, that it's going to give us consistent, predictable results. And so we find this tool under Stat, Quality Tools, Process Capability Study. So we can take a look at this in normal or between within. So let's ask first, what is the data we have? So let's go back and we'll go to Stat, Basic Stat, Graphical Summary. We'll put data in and we'll say, is this data good enough to have a normal distribution? Okay, so here we see the data actually is good enough for a normal distribution. So the p-value is greater than 0.05. which is the rule that says that the data is normal. So we can use this process capability analysis normal. At this point in time, if the data is not normal, we would want to transform the data. If we want to do a transformation, we would go to Control Charts, Box-Cots Transformation, and affect the transformation there. However, what I'm going to do is say, warn you, talk to a master black belt or a black belt in your organization before you do any transformations, because these things will be shape changing and they were going to now create a gap between what is in the normal world and the numerical world. So the normal world, we see the raw data. In the numerical world, it's going to be changing in shape so that it looks like it's normal data, even though it may not be. And so we have to be very careful how we're going to use that. So for green belts, basically what I tell you is don't transform the data. Transforming data and dealing with transformed data requires a lot more sophistication than we try to teach at the green belt level. So just because we have non-normal data doesn't mean we can't deal with it, but again, it's a higher level of competence in what we teach in this class. So we do have normal data, so what that says is we can be comfortable in going to Quality Tools, Capability Analysis, and Normal. Okay. And when we click on this, we see the data are in a single column. So that's data. Subgroup size is 1. Now, we could use larger subgroup size. And what it will do then is it will actually break them and then average within those subgroups. So we'll take a look at the first 5, for instance, if we said 5 sample size, then the next 5 and the next 5, and it'll give us the average results. However, because we're dealing with real-world type of data, we probably don't want to do the averaging because that's going to then diminish the overall results we see in terms of the total amount of variation. Because when we average in those subgroups, what happens is we lose the extreme values. So what's the lower spec? Well, in this case, the lower spec is going to be 598, and the upper spec is 602. Now, we don't have a historical mean, but we do have some other things that we can deal with. So again, I don't want to do a transformation. I don't want to estimate things, but I can take a look at options. So the options is I would like to have nominal is best, or 600. Okay, and I can display parts per million, or I can insert confidence intervals for 95%. Okay, so this is now going to be able to show us what we see in terms of the probability of performance for this result. And we'll also see our compliance relative to the target level. Okay, we're not going to store anything, and so we click OK. And here we get the process capability. And notice there's nothing in the session window, so everything is on the graph. So here we see, here is the data. Okay, so here is a problem that we see first of all. Number one is the calculations were actually not done for black belts. These were done to fit the automotive industry. The automotive industry wants you to calculate and deal with something called PP. The problem is the formula for PP is long-term variation. But if we're taking a look at what we're actually doing, we're only dealing with short-term variation. And so long-term variation is actually not something we even see in the process. So these data here for PP are really not very helpful. The data we have for CPM is helpful. This is the performance relative to the target. And we see that's a 0.35 and the lower boundary is a 0.31. That's not very good performance. Remember, 3 times that number, it would be in the sigma levels for calculations. That's basically a 1 sigma process. The design CP is a 0.4, and the confidence is it's somewhere between 0.34 and 0.45. Again, nothing to write home about and brag to your parents that we did such a great process about. Certainly, you don't want to tell your boss that this is the best we can do. And for CPK, which is always going to be worse than CP, we see we also have a very broad band of performance. So again, we see the limits up here, so the upper spec limit and so forth. So we might ask ourselves, what actually is this process doing? How do I want to set this performance? So how did we set the spec limits? We said 598 and to 602. So is that really what we want to do? So maybe if we edit the last dialog box, and now we're going to play this little what-if game. Okay, so if we edit the last dialog box and we say, let's come back here and say, what if this was 597? And what if this is 603? And we wanted to have performance within that boundary. We say, oh, what happens? Well, the process got a little better, but it certainly isn't at any level where we say we have absolute confidence in this. So maybe I have to come out here to 595 to 606. Okay, so if I again edit the last dialog box. So I say 595 and let's say 605. Okay, now the design process is at a 3 sigma level and it's performing just below that and performs relative to target. So we see that there is still some variation in this process that says this process is not predictable. So if you had a process like this in the control phase, and I'm going to be the master black belt reviewing your process, I'd say it's not ready to go into state of control. There's too much variation in the process. We have to understand what's going on in this data set. So process capability analysis can allow us to see, are we actually ready to put that process into full-time performance or not? Now let me just show you a couple of other things here. For instance, what do we really want to share with your boss when you're showing this? So this performance data down here, I probably want to delete that. Other things we might want to take away. We might want to take away using the 95% confidence interval. The boss doesn't care about the standard deviation. The PP statistics in here are not helpful. And so even just showing potential capability or overall capability of the process. These are things that would be helpful for the boss in terms of understanding. But at the same time, we don't want to confuse by having more questions that are raised that actually have been answered in the analysis. But in the graph itself, just causes a diversion in terms of the conversation that you're trying to have with your management about how you improve the process. So the next thing we want to do is realize there's 2 components to process performance in terms of the control phase. Step 1 is, does the process meet the customer requirements? So that's by the spec levels. And the next one is, and how is it performing relative to consistency of the process itself, and we'll see that through the process control charts. So what we've seen now is we can now detect a closure of the system and say, wait a minute, it's going out of control. And we can see the difference in terms of process control. Remember, process capability analysis will show us the enumerative result. But to actually detect it moving out of process capability, we need to have the real-time monitor. And that's what we will take a look at when we look at our next module, which is on statistical process control for real-time operations.